Well, we are solving NEET 2017 question from Mechanical Properties of Fluids. The problem is like this. A tube contains both the ends open to the atmosphere, partially filled with water. So, I have something wrong with the diagram that is given for you. To tell you how it is wrong, I will draw a fresh diagram and show you what is actually given for you. So, consider an a tube. Let me draw an tube. Like this. It is now partially filled with water. Both the ends are open to the water. So let me draw the water. As it is partially filled with water, what happens is water adjusts in the U-tube in such a way that initially water levels are same in both of them. Like this. This is how water is filled. Now what happens is oil which is not going to mix with the water is poured on one side until it stands at a distance and 10 millimeter above the water level on the other side. So what he is saying is from one side you are filling with water like this. Sorry, filling with oil. So when you are filling the oil, what happens is it pushes the water level down here so that it pushes the water level up here. So what happens is you will get oil here. So I am drawing the oil with the blue color. It push this water down and rises on the other side. To show that, let me just remove a bit of the water here. Just, yeah. So sorry. Yeah. I will I may remove a bit of water here, and this water is actually occupied by oil like this. And obviously, water on the other side is rising. So, this is how the diagram transforms. Transforms in such a way that what he's saying is it is poured into the one side until it stands at a distance 10 millimeter above the water level, right? So when compared with the water level, oil stands at a height 10 millimeter above. So this is 10 millimeter. This is 10 millimeter. This is the final diagram that what he is saying, right? Meanwhile, water rises by a distance of 65 centimeter from its original level. So, as I told you, it's originally it is this diagram 65 and 65. So, water has raised from its original level by 65 plus 65, that is 130 mm. Right. So, in this part of the diagram, like what are we saying? Yeah. In this part of the diagram, this must be empty, no water. Whereas in the other part, oil is poured in such a way that that is 10 millimeter above. So there must be oil. So here having oil is fine. But here in this part having water is wrong in the diagram. While it's copied into the book from where I have taken, it has taken wrongly. As I told you, this part has to be empty. So I will use a pen to erase that part. So there is no water actually. This part is empty. This has to be like this. Then only we can solve it. Right? So I want to be careful in understanding that. Now solving the problem is Quite easy. What we can say is these levels are same. So pressure at this point equal to the pressure at this point because levels are same. At this point, pressure is due to atmosphere as well as the liquid. So P naught plus P oil. At this point, pressure is again due to atmosphere and water. So P naught plus P water. P naught and P naught will cancel. So P oil equal to P water. We can write the pressure formula as force acting per unit area. If that force is due to the weight, I can write mg by area. Mass can be written like volume into density. Volume of the tube can be written like area into length h rho g by area. Area cancels, so the formula for the pressure is h rho g. So pressure due to the oil is height of the oil, density of the oil into g. Pressure due to the water is height of the water, density of the water into g. G can cancel. Height of the oil is from here to here. This is the height that you want. Here to here is 130. Here is 10 more. So that will become 130 plus 10 millimeter, of course. Density of the oil I have to find out. Height of the water is from here to here. That is 65 plus 65 in the diagram. That is 130. Density of the water is 1000 kilogram per meter cube. That implies density of the oil is 130 by 140 into 1000. That is 13 by 14 of 1000. That must be very close to 900 and above. There is no other answer other than this. So I need not even calculate that. 928 kilogram per meter cube is the answer for the problem. So be careful in understanding the problem. The only thing that I felt wrong here is this lag. He has given that as filled with water, but it's not filled. That was actually empty. That has to be empty. Then only you can get to this answer. That's how we have to solve the problem. Thank you for watching.